This lab is called the Distributed IoT Platforms Privacy and Edge Intelligence Research Lab. Simply put, the DIPPER Lab. You know, when it comes to the African continent, there's a lot of issues with traceability. You can take it either from the agric domain, the health domain, or the energy domain. So, for instance, agric domain, food. If you take red palm oil, you've heard of the incidence of adulteration. How do we make sure that the food systems that we eat are from a good source, from where they were produced to where it eventually ends up on the shelf? How do we make sure that no adulteration has occurred, right? This type of thoughts led to the conception of the lab, where we thought that, okay, is it possible for us to develop local-based solutions where, for instance, we use existing disruptive technologies to provide some form of traceability in the supply chain?
Here in the DIPPER Lab, I basically lead research implementation. In the DIPPER Lab, our main concentration is on IoT and blockchain research. So one of our most popular research works here is where we able to identify Sudan 4 in red palm oil using a basic tool as basic as a smartphone.
We thought of what existing technologies abound and then said, okay, blockchain, which is a leading contending technology, could help solve some of these issues. But blockchain does not work in isolation, right? You need some sense of tools or sensors to gather this information. So IoT came into play. Then to also see the changes in the food or the quality in the food or the quality in products or something, it's an anomaly. So anomaly detection. Anomaly detection is AI. And most of these things, we look at technologies that can be used to detect them in a sub-Saharan African situation. Realize that phones, right? There's everybody, more or less, if you sample, people have access to phones more than they do to good drinking water. So if you have to develop this type of solutions, then one of the solutions that can help us achieve our aims or to have quick, rapid prototyping traceability checks will be phones. But AI models are very large, complex. So edge intelligence, right, in the name of the lab comes to play. So edge devices like iPhone. So how do we develop models, right? How do we develop tools that can work at the edge layer? So looking at bringing all this concept together, the name DIPPER Lab was born. And from there, we've been doing interesting research within the university.
My research focused on building a tracking and monitoring device for cattle. We call it HeadWatch. HeadWatch is basically an IoT device that is going to collect some data from cattle, like their location, their movement pattern, their grazing pattern, their temperature, and their heartbeat. With this data, we are going to be able to monitor their health, where they go to, and when the animal is hurt or when it is not moving. With the data that we are going to collect from the animal, we'll be able to determine that with the help of the AI team. So this is also going to help us solve the problem between the farmers and then the herders, the ones we know as the Fulani people who take care of the cattle. So if maybe a Fulani person brings a herd group of cattle to your farm and then they come and cause damage, and you go to the owner himself to complain, and the owner is like, my animals didn't come to your farm or anything. Like if there's an argument, with the help of the HeadWatch, we'll be able to know that the animals were actually there in your farm using the GPS tracking devices that will be embedded in the system. So that is one of the problems that the HeadWatch seek to help solve. And also for the cattle owners themselves, you'll be able to keep track of their animals, their health, the number of cattle they have, and when even the cattle gets lost, they will be able to detect it quicker with the help of the device.
My main work focuses on the development of a smart system that leverages the Internet of Things, otherwise known as IoT, to assist in the early detection of galamsey activities here in Ghana. We have seen over the past few weeks the adverse impacts of galamsey activities on our river bodies. And I believe that is just the tip of the iceberg, as this can impact our crops, our foods, and therefore impacts we ourselves and our livestock. Now, in the detection of the pollutants in the river bodies like mercury and lead, there's a long process that this has to go through, such as environmentalists visiting the river bodies, sampling the water, taking it to their lab and testing it. And as we can see from this process, it is a long and tedious task, and if a river body is to be polluted, it will be known a bit late. So our system is going to help in the early detection.
We are a university, a research institution, so we usually think of journals, right, as major achievements. But when we conceived the lab, we realized that we cannot keep on doing the same things as we do, the same method, and expect different results. One of the key things that we sought to do is to do some sort of what we call knowledge transfer partnership. Some of the cutting innovations that we are doing in the lab, how do we make sure that it's transferred to industry? So we paired up with SMEs within the local ecosystem, and then we are doing interesting things with them. One of them that I can say is SESI Technologies. We are developing some interesting tools with them that's tracking food from the farm to your table, right? So we call it an agro-trace solution. This is having a multiplier effect on the system, and especially for smallholder farmers. This is one of the things that we've been able to do as a lab.
When I first received this idea, I wanted to start implementing it, but upon discovering that I needed a wide range of tools and materials, I thought to myself that I would not be able to implement it at all. But upon joining this lab, I have access to a wide range of materials, tools, and assistance from my supervisors. And in this way, the lab has helped me a lot. The project is in its pilot stages. We are still going through the prototyping and the testing of our system. And when this is ready, we will be able to mass produce it and implement it here in Ghana. And I believe that without this lab helping Ghana, especially the issues of galamsey, will not be possible.
Coming up with electronic device like that, a product, you have to go through some design processes. You need to design, prototype, test, and then you start manufacturing. But then getting some of these machines and tools for prototyping was a bit of a challenge. But then when I came here and then we discussed the project with our supervisors, they showed really good interest in the project, and before coming here we didn't really have a workstation for electronic prototyping. They were not enough. What we had was just a soldering station. But then after telling them this project and they showed interest in it, they have provided us with a lot of tools, a lot of electronic tools. Now we have a PCB prototyping device with everyone, which is helping us to prototype our designs, and we also have 3D printers that are being used to print out our prototypes, to test them and see how they work. And then also we have some new devices too here, like a microscope, electronic microscope, to cross-check our design before we put the components on them and then go out for field testing. For DIPPER Lab, what I would like to say to them is a very big thank you to each and everyone in the lab who is supporting us coming up with this project, especially our supervisors who are always there for us, and the PhD students here who has also been supporting us throughout this project. I would like to say thank you to them and God bless them.
They say the sky is only the beginning, right? So for us, we see that the foundation is set. The college attracts some of the best talents within the country in engineering. We have the best talents. One, we want to be able to retain the best talents locally, right? And we are developing them right from third year, second year, third year. They do their internships here. They learn about blockchain, AI, IoTs, and then they do their national service. At the end of the day, move outside. We want to prevent that. We've been able to do that to that extent where now even students who come to the lab are able to reject lectureship appointments in other universities, says that we have a bright future. So once we develop the talent, then we have a pool of people who can now develop solutions for the ecosystem. So we are a research lab, don't want to compete with agri-techs, but we are developing talents that will go up to set up startup companies to be like the Pharma Lines, the SESI, all those big companies, right? So we want our impact to be felt. That is the first thing. We want that farmers, smallholder farmers in the future, maybe not too far, 5 years down the line, when a smallholder farmer in a drop born sow farm planes goes to the farm, at the end of about, let's say, a cropping cycle, he looks at the toil of his neighbor and say, if not for DIPPER Lab, this would not have been possible. These are success stories that we want to tell. We also would like to reinforce our knowledge transfer partnership agreements, right? Usually people had accused we university researchers that once we are done, we publish in impact factors, that's all. We want to change the narrative, and we are beginning to see this bear fruits.